Hello. We're going to solve two simple machine problems. The first one's going to be calculating the IMA of a screw system. As you notice here, we have the screw here, but we also have an arm here that helps us turn the screw. From the center here to the edge where we're grabbing is 8 inches. We have some thread notes here. I want to remind you what the thread notes mean. Remember, this right here is the diameter of the screw down here. That is 1 1/2 inch. The 6 means 6 threads in an inch. So if we counted off 6 threads from here to here, 1 inch, there should be 6 threads, and that should be 1 inch. And the NC means it's coarse threads. Okay. As always, we need to start with what we know. So what do we know? We know from the thread notes here, pitch is 1/6, the reciprocal of the threads per inch. We know that the radius of our turning arm, we're not going to use this radius because our hand is actually up here. So the radius is 8 inches. And we actually know that the circumference that's getting turned for 1 revolution is 2 pi r, which we'll plug in that r there. What we don't know is right now our circumference, which we calculate or substitute in and plug in, and the IMA. Okay. So on all these problems, we know that the IMA equals dE over dr, but let's make sure we understand what the dE and the dr mean here. The first one, the dE, is the effort distance. It's the effort to turn this handle all the way around for 1 revolution. When that turns 1 revolution, this thread rises 1 pitch worth out of the block there. So the formula here is probably better written as C over pitch, which tells us we should plug in 2 pi times the r of 8 inches divided by 1/16 of an inch, and working that problem out, we get approximately 302 for mechanical advantage. So that's our first problem that we worked. Second problem we're going to be looking at is a winch problem. So we're given some distances, we're given a weight. We also should note here there's no friction. Keeping the problem simple. So let's write down what we know. We know that the dE, our effort, is from here to here is 1.25 feet. Now what is that? That is a radius because the line calls it out from here to here. So what is our actual number for our diameter? Should be 3 feet. And our dr here is, and you see that specifies a 4-inch diameter, is 4 inches. Already do you see there's a problem? Of course, let's convert these to the same units. So this should be 36 inches to 4 inches. And what else do we know? We know that we've got a weight or resistance, Fr, of 100 pounds. Okay. What is our unknown? What we don't know is our Fe, which is the F there. So we're calculating FE. So with no friction, we can say again that IMA equals AMA, and the formula for IMA is DE over DR, and the AMA is FR over FE. Solving this, I recommend that you always rearrange your formula before you substitute any numbers in. So we're solving for FE, so FE, and I'm doing this in my head, but you can swap these two numbers out, and you can swap these numbers out, or that times that. That comes up there, this comes down there, so we're left with DR times FR over DE. Okay. And what do we come up with here? DR, what did we say was 4 inches? What was FR? 100 pounds. And our DE was 36 inches. Okay. Grabbing my calculator, 4 times 100 divided by 36 equals something close to 11.1. And what are our units here? Pounds. Okay. So we find that a youngster would have no problem lifting that 100-pound bucket of water out of the well. Okay. Thank you.